Our first presenter is Jeff Houston, the absolutely wonderful and inimitable Jeff Houston. He says he is not good at jokes, so I thought I would open with one. Who used the internet before it was cool? HTTPsters. Like hipsters? Okay. Yeah, that might be another one that needs to be written down. Fair enough. I'd like to introduce Jeff Houston, who will be presenting Triggering QUIC. Jeff is the chief scientist at APNIC and has traveled from Canberra in Australia to join us today. He can't recall how many times he's presented at NANOGs. It's been a couple, you know. Jeff's first talk at NANOG was Won't Get Fooled Again at NANOG 35 in LA in the year 2005. He's completely forgotten what he said, but it was probably wrong, and he was indeed fooled again. Welcome back, Jeff.
You know, it strikes me as odd that here you are on, I think, at the forefront of the technology push. And quite frankly, the last 40 years has been an amazing ride. Now, when I say the last 40 years, through the lights, I can dimly appreciate that only a couple of you were alive back then. Most of you, all of this has happened while you have watched it from, an infant onward. But oddly enough, this technology, the core of it, is 40 years old. It's about 42, 43 years old. Even Ethernet is 50 years old. You're not at the forefront of technology, you're playing with the trailing edge. That, quite frankly, a lot of this stuff got done and then never changed. And that, to my mind, is an amazing statement. Imagine in civil engineering building a bridge that carried 3 horses and a cart. But the same design, the same bridge, is now carrying 1 trillion cars per hour, per second. You can't do that in a lot of the physical world. But oddly enough, in this world of engineering, design, and protocols, we've done precisely that. That almost without thinking, a lot of the underlying engineering was phenomenally scalable, yet at the same time invariant. So this brings a question. How do you innovate when a whole bunch of this stuff is kind of unchanging? We have seen the IPv6 transition. Oh my God, I was chairing a working group in the early 90s about the transition to V6. And the pessimists in the room said, oh, it's going to take 5 years. It's going to be forever. 40 years later, and you sit there and go, no. And I just heard yesterday with a question, or was it the day before, about the design of the Wi-Fi system for the 2034 Olympics. Oh yeah, we're just going to use dual stack. I'm sorry, you're condemned to this transition for your lifetime, and probably the next one after that, and so on and so forth. We're never going to get out of this mess, I'm sorry. So change is really hard. At the same time, we need to move on. And this is what brings me to QUIC and a couple of other things. Because TCP is beyond its use-by date. It was great for what we needed in the 80s. It scaled up to gigabits per second. It is truly an amazing transport protocol. How does it handle remote procedure calls? Doesn't. How does it handle multiple streams? Well, it doesn't. Header line blocking. How does it handle radio telecommunications when you get a number of packet losses that aren't congestion? Well, it just collapses. Can we do better? Yeah. How? Well, we're just going to have to change the way TCP works, of course. Well, easy to say, bloody hard to actually do. Because if you think about it, right the way from that NAT that sits somewhere very, very close to you, that looks really hard at the packets that flow through. That's a TCP SYN packet. I need to set up a new binding state, get a new external protocol, port and address field. I need to do all this magic. Then I watch the flow like a hawk. And as soon as I see a fin, tear it up, send the addresses back to the pool, do it again. How do you put in a different protocol in a NAT? You're going to change and reprogram all those billions of NATs? I'm like, it doesn't work like that, does it? And then you get to load balancers. You get a whole bunch of middleware that peeks inside the IP packet going, hi, transport, what are you doing? And you get to the realization that the only thing we've really played around with in TCP for quite some years has been the congestion control algorithm. Why? Because it only happens on the server side. I don't need to change the client, and it still looks like TCP. So you go and play in this tiny sandbox because that's the only bit you're permitted to play in. But at some point you realize, I want to do more. So what do? New protocol? Go away. Can't go there. But I want one. So this is the design of QUIC was an elegant compromise. Because you see, there's also UDP. And maybe it's thanks to the DNS, yay, that the DNS is universally supported. So, you know, UDP, port 53, TCP, port 443, are kind of the universal protocol tunneling for transport. And the magic thinking behind QUIC was, if I can't change protocol 6, if I can't change the control patterns in TCP, why don't I just put it in UDP? And as soon as you have that thought, you think, Christ, that's brilliant. Why can't I just do that? There's nothing stopping you. But what if people look into the packet? Oh, it's okay, let's encrypt it. Nothing to see, can't see a thing. Oh my God, what's the user doing? I have no idea. Well, what about fragmentation? Don't. The maximum size of a QUIC packet is basically 1200 octets. That's it. It doesn't fragment. You're not allowed to. So all these problems that beset the DNS, all of that issue of, UDP to TCP transition, QUIC doesn't do that. And all these problems that we've had about intrusive network behaviors that peer inside the packet going, you're going too fast. Let me drop your window size for you. Thank me. All that behavior, it's impossible in QUIC because you can't see it. It's entirely encrypted. And the thinking then is, well, I don't need to reproduce TCP. I can go a whole lot better. I can do multiple streams inside single sessions. I can actually number frames so that I never get the ambiguity of, is that a duplicate packet or a retransmission of an older one that's lost? No such ambiguity in QUIC. I can do all kinds of things inside this that I couldn't have done with TCP. And last and not least, just take a step back and look at the industry. Who's got more money? AT&T or Google? Nah. All the money has moved up the application stack. Carriage is a toxic wasteland. And even with the current fervor of building AI data centers, let me assure you, that will die out. There's no money in infrastructure. The money, the trillions of dollars, is way up the stack. And interestingly, in QUIC, you're not waiting for the operating system to give you a library for this latest transport protocol. It's in user space. It's my app. All of that work is now app-centric. And that precisely matches where the effort, engineering know-how, push and investment actually matches. The internet is now an application protocol. Everything below it, nah, it's just commodity. Which is fine, I suppose, for folk like Nanong, as long as you realise you're sewerage engineers. It's a tough job, someone's got to do it. The margins are grim, but someone's got to do it. And for that, I thank you. But the action is way up there at layer 7. So QUIC is an instantiation of that. It uses UDP port 443, and from the point of view of the network, there's nothing much else to say. It's been around for a while, 10 years. And the next trick is, and the precedents are horrible, how do you transition? Oh, just do it like the way we did V6 and V4. Yeah, right. How many transition plans were there to go to V6? You know, I can take a book on this, and 35 is where you start, and it just goes up from there. Talk about confusing the industry with a bunch of enthusiastic geeks who refuse to listen to each other. V6 was a classic textbook case of failure all the way through because we never made it easy. You know, everyone had their own idea of how to do it. We confused operators, we confused customers, we confused vendors. So let's not do that. How do you introduce a new transport protocol? Well, you have to remember a few things. And the first thing is, we are astonishingly intolerant. Delay is the worst possible thing you can do. So, oh, just try and see this, and if it fails, let's do it a different way, kind of says, well, I send out a packet, and then I go, I think I'll have a cup of tea. Did it come back yet? That's no way to do it. When you want to see if something is supported, you'd like to do it in a way that takes almost no time at all. Now, the way Google did it in their browser, Chrome, is that they said, let's not jump to QUIC. Let's wait to see if the server at the other end says, I can do this. Well, how? Well, the most malleable place to do that is content. So what Google did in Google Chrome was, inside the headers, you put an alternative service header. It's kind of, if you come back to me sometime in the next 24 hours, then we can do QUIC, which is kind of a nice idea. It's instant. The server said, yeah, the next time you try it, I'll answer on UDP port 443, let's play. And that was kind of bubbling along for quite some years, and it's not a bad idea. So this is since 2020 in production Chrome. And I suppose the reason why they did this, it's conservative. Because when you have a piece of software that's used by basically 65% of the world, that's what, a few billion users, you can't do overnight change. You've got to gently slide it in. And their version of gently slide it in was, I'll put the capability in the engine, but it won't be turned on by default. The server at the other end has to say, the next time you come, we're okay to do this. And of course, if it doesn't work, you fall back and life is fine. So this was announced some time ago, 2020, and has been just sitting there quietly. So if you look for QUIC, if you peer into the network and go, show me all the deep, dark UDP port 443 packets, then all of Chrome does it. And if I try and trigger QUIC, I should see 65% of the world's users do QUIC. Yeah? Now, not every server supports it, so I have to kind of push it a bit, but I should see a decent amount of QUIC if the server supports it. Intuitively, that's a good answer. Practically, it's bullshit. So it's only effective when you come back. So let's talk a little bit about HTTP2. Remember HTTP2? The one with persistent connections? Grab object 1. You're about to grab object 2 from the same server, aren't you? Don't close the session. Keep it open. Grab object 2. Grab object 3. And because we actually deconstructed the web into a whole bunch of smaller transactions, HTTP2 was brilliant because it's kept the session open, it kept the TLS encryption state opened, it cut down the time to do all those myriad of tiny fetches because it just bundled them all into the one TLS session, the one transport session. So when is the second time? Well, it's actually really hard to do this, because if you sort of go, here, next time use QUIC, but it's going, I've got this HTTP2 session open. There is no next time. We're just keeping this open for as long as we can. So in some ways, it was a nice idea, but HTTP2 was sort of in the way. So that second visit is a real problem to actually see a whole bunch of QUIC uptake. Oops. How do you get around it? We're doing a lot of measurement in APNIC. When I say we, I mean me and Joao. There are two of us pedaling the bicycle pretty hard. And trying to actually artificially create the instance where HTTP2 goes, now I'm bored, I'm going to shut down. Now you go, let's try it again. We did this ad, which had a clever little script in it, because all ads have scripts. And what it does is it retries the same object 8 times, but waits for 2 seconds, and the server says, keep alive interval 1. Now, even though that's a suggestion, because the client has actually got control of the session, it's kind of, for Christ's sake, will you shut down? And sometimes in those 8 retries, it will go, aha, you're going to use QUIC. And doing that, we kind of flush it out. But God, that's a lot of work. That's a huge amount of work. When Apple decided to actually take the Apple ecosystem, which is basically the Safari browser on no matter what device you have in your pocket, then they used a different mechanism, because deep down in the mine, and it was actually, I think, some folk at Google originally, but now that knowledge has spread everywhere, came the application view of the DNS. Anyone thought the DNS was just translating names to addresses? You're part of the old crew from 40 years ago. That's not what we'd use the DNS for. The DNS is now the Universal Distributed Database, and these days it's almost the Universal Transport Protocol. There's an amazing amount of information you can stuff in the DNS. The whole idea is now, remember delay is terrible? One DNS query, one answer, the next packet is data. The next packet moves straight into establishing the session. You don't go and ask for a bunch of stuff. You ask a single compound record. Tell me everything I need to know to make the next packet a connection. And this produced what they called the service records, which has had a mixed uptake. But to simplify it, thank God, because I'm a simple chap, they made one of these records the record for HTTPS, and they called it HTTPS. I like that. And it has an application level protocol field. So in the DNS, you can say, hey, I'm hip, I'm cool, I can do QUIC straight away. If that record is there, Apple said, let's use it immediately. So if you say in the DNS, this service name is QUIC capable, you just do it. And Safari just does it. Supports QUIC via this DNS query, and it's triggered immediately. There's no wait, nothing. If you support QUIC and the DNS says you do it, Safari just jumps straight in. So, Chrome, very dominant worldwide, about 65% of users, as I said. Safari is doing it differently. What's Apple's market share globally? 15, 16% around there. So if a server is QUIC aware, it should see a bunch of stuff using QUIC, one way or another. It has both the alt service directive and the DNS. We're cool, right? Wrong. Cloudflare's been supporting QUIC for ages, probably since 2020, I've forgotten. But they measure it. How many folk come to us and use QUIC? 85%? No. 31%. That keep alive problem in HTTP2 is actually really quite prevalent. And so the true extent of QUIC capability isn't visible by just casually looking at websites and looking at traffic. You've actually got to really peer hard. And in our case, as I said, we hammer at you. If you're unfortunate enough to get an ad from us, and about 35 million a day are, thank you, Google, they do a great job, we push. And if you've got QUIC capability, we will see it. And around 75% of the world are now perfectly capable of doing QUIC if you're persistent enough in trying to set it up. The red line is actually what happens when you push and push and push. The blue line is the bottom, the first query, the first fetch. Chrome doesn't do it the first time. So this is really a measure of Apple's market share. The red line is what happens when you really push hard. So who's doing HTTPS queries? Well, the answer is Safari. Down at the bottom, the yellow line that you can't see at the back of the room is Chrome. 3% of users in Chrome actually do this query. I suspect Apple says, if you're running Chrome on my platform, my rules apply. And I think the query is actually coming from the Apple part rather than the Chrome application. But that's Apple for you. So the total is actually around 30, 40%, but it's really all Safari that is doing most of the jobs in making these queries. If you look at Chrome, that tiny 3%, there's something bizarre going on. Weekdays have more use of this query than weekends. It's enterprise networks, which is odd. Has the Mac and the Apple infrastructure leaked into the workplaces all over the planet now? Is that what's going on? I have no idea. But it is curious that these are one of the few where you actually see weekdays and weekends are noticeably different. So, Chrome does do these queries, but it's really not sure if it's the Chrome browser doing it or whether it's just Chrome in some kind of Apple platform. So, both major browsers support QUIC. It's pretty high everywhere. Everyone should do it, right? Who blocks port 443 on UDP? The redder the country, the more likely the block. And so what we see is Iran and China, and almost, and the Falkland Islands, because, sheep or something. Iran is weird. It's kind of, the red line says, I let it through for a while, and then a few months later, no, I didn't mean it. And then it goes, one major provider is letting it through, but the others aren't. Oh, and by the way, the blue line says there's almost no Apple infrastructure inside that country that's allowed to do anything over port 443. So Iran's kind of, we're not quite sure what we're doing. The rules keep on changing. That's Iran. China, confused. It's a big country. And quite frankly, I think it's a free-for-all internally. Folk just do stuff. So in some ways, there's a fair deal of port 443 blocking, but not everywhere. And a few months ago, one of the big majors, and I don't know which one from this graph, I could have to look it up, turned it on as well. So 20, 30% using QUIC, so it's there in China, which kind of surprises me because we've heard a lot over 20 years about the Great Firewall, and this stuff is opaque. You can't reach in. But there's still a sizable amount of use of QUIC from within China, so, go figure. QUIC doesn't fragment, so all those endless arguments about the DNS fragmenting packets, just use small packets and get over it, dude. And that's exactly what QUIC does. It's kind of settled on 1280. Why? Because V6 did. Why did V6 do it? One number's as good as any other. There was no science. But QUIC keeps the packet sizes very, very small. So alt service is supported. HTTPS is supported if you're in the Apple infrastructure. So we're kind of working there, right? But, adding a new query to the DNS is a cost. Instead of querying for an A record and a quad A, we now have to query for an A and a quad A and an HTTPS, right? This is bizarre because inside the HTTPS record, I can put hints. I can say, not only do I do QUIC, but by the way, my v4 address is here, my v6 address is there, go use it. And if you do that, and get rid of the A and Quad A records, and you'd be a brave person to do it on a popular site, all the modules, all the nodes that are actually looking for that record go, yeah, fine, I'm cool. I can do the entire thing from one query. If they're not ranking the query, they don't get anything at all. But it is pretty surprising. So now I'm looking at who's making queries. And again, what you're finding is HTTPS is about 8% of the world's query rate because of Apple infrastructure, because Chrome doesn't really do it. If everyone does it, that would be way up there on a par with A's and Quad A's. And now some numbers. Oh my God, it's so far away. I need a long distance telescope. Looking really hard. Safari Chrome. A small number of folk do the query. I think they're running on Apple, but very few follow up with using QUIC, because I think the browser's going, I'm running on Apple. I'm just going to revert back to using HTTP2. So Chrome doesn't do a DNS HTTPS query. Safari, Apple are an odd crowd. And I think Apple do actually try and say, when we make a change to the world's internet, we're going to stage it. We're going to gently introduce it. So while 96% of all Apple endpoints actually make the query, only 75% follow up with an HTTPS session. 25% are kind of going, I'll wait until tomorrow. Maybe you'll be ready by then. So there is a 25% gap there where I think Apple is gradually turning up that dial and actually filling in the blanks. Because the last thing you can do in today's internet on a very, very popular platform is introduce a change overnight. It doesn't work. Does Safari also use alt servers? No. And I looked and it's not there. So no, it doesn't. So what does that mean if you're publishing content? You've got to do both. Now hang on a second. Why is the IETF meeting next week in Montreal? To amuse themselves? Possibly. To create standards, to make the life of all of us easier, to create interoperability? Well, yeah. So what happened here? Oh no, you've got to do both. Why? Well, they're both standards and neither of the popular browsers supports the other choice. This is ridiculous. How did we get to this point where, 40 years of experience have taught us that follow your own path is what you have to do in networking? I'm like, it's insane. And you say to both of them, get your act together, guys. Stop banging the rocks together and actually agree on doing something. Why do 24% of the Safari users still not doing QUIC? Well, patience. And I also found a really odd bit. There's no HTTPS trigger. There's no initial query to say, I do QUIC, but 1 in 50 Safari users go, I'm feeling lucky, dude. Here's a packet on UDP port 443. Let's see how we go. And of course, if they're coming to my server, the answer is, if that's what you want, that's what you get. So that's where we are with this. And I think it actually says a fair deal about the enormous amount of effort you've got to go through if you're big to introduce changes in the internet in something as fundamental as transport. But I would also say, if you're not changing, you're dead. And in some ways, TCP really, really needed this forklift. We had to do a better job. And QUIC is about the only way I can see at the moment of lifting that part of the technology up into the 2020s. So I hope that was interesting. I think I've run out of time. There's 1 minute and 21 seconds for questions. So if there are any, I'd be happy to, try and guess at the answer. Thank you.
Is anybody in the room? Is anybody? Aha, we have one. Excellent.
So Chris Rapier,
Affiliation?
Pittsburgh Supercomputing Center, part of Carnegie Mellon University. I have a question about the applicability of QUIC across different path environments. If you have a lossy path, if you have a high delay path, if, does QUIC work effectively across every path? And are there some applications where QUIC might be a problem? So for example, the small MTU size, does that have any impact on increased CPU overhead? Or anything like that?
These are all really good questions. And I think what it exposed is that the thinking from the 1970s was too crude. And we said, that's transport. But in actual fact, it's not transport. There's an issue around framing and presentation, and there's an issue around control, congestion control in particular. QUIC does not change the congestion control algorithm. It makes it opaque, you can't see it, but most implementations of QUIC, unfortunately, still use cubic because, you know, banging the rocks together is so much easier than using BBR. Some of the ones use BBR and actually do a much better job. So QUIC can be as good as you want. It's what you put in as your congestion control.
Okay.
Where you lose is actually the work that's been going on for poor, suffering CPUs, where Intel's smart interface cards do TCP segmentation offload for you. Geez, thank you very much. There is no possibility of segmentation offload in QUIC because of the encryption issues. So what that does mean is that if you're going to wait for Intel to actually introduce some changes into its ASICs to do offloading QUIC support, it's a bit of a race between Intel going broke and Intel actually doing the work because, you know, they're struggling. So that's still an unsolved question.
Or Intel doing it correctly.
Oh God, I'm not waiting for that.
One quick question, hopefully. Quick about QUIC.
Very quick. Klaus from BR Digital. Why SCTP was never an option?
It wasn't invisible. NATs needed to change, load balancers needed to change, everything needed to change. You can do it on your private Ethernet and who gives the stuff. But as soon as you tried to roll it out, NATs went, I don't know this packet, discard. Every single security firewall in the world went, discard. You know, you can't do this kind of stuff in today's infrastructure. To be perfectly frank, if you want something to work, you've got UDP, port 443 or port 53 and not too many others, or you've got TCP, port 80, port 443, or you've got a drop packet. And SCTP and a whole bunch of V6 transition mechanisms fell down the black hole as a result. We're not a very flexible network these days, sadly.
All right. Well, thank you very much, Jeff.